In all current Peugeot vehicles, motion is transmitted to the front wheels by means of two shafts of unequal length, each comprising a constant velocity joint at each end. A short shaft on the left, a long shaft on the right, usually supported in an intermediate bearing. The transmission shafts come from two main sources, GKN or Glenser manufacture. These shafts have a fixed tripod joint at the wheel end, designated by the term GE or Glenser extérieur, and is recognized by its spherical mild steel outer member. It's associated with a sliding tripod joint at the gearbox end, known as GI or Glenser antérieur, recognizable by its steel sheet outer member. The diameter of the outer member and that of the sliding tripod give the classification of the shaft. This type of transmission system is used on vehicles with engines of low to intermediate power. PSA manufacture. The joint at the wheel end is of the ball type, R-Zephyr joint, identifiable by its machined steel outer member with a large step. With a sliding tripod at the gearbox end, known as JB, with a short outer member in machined or ordinary steel. The diameters determine the categories. This type of shaft is for engines of intermediate to high power. The GE or R-Zephyr joints have an inset phonic wheel in vehicles with anti-lock brakes. There is also a mixed GKN transmission system. The connecting shaft between the joints is solid or tubular in various diameters. The threaded end to accommodate the hub nut has a diameter corresponding to the type of vehicle. The nut is immobilized by pining into two slots or by means of a pin. Dirt is kept out of the joints by gaiters that also contain the reserve of grease. The gaiters on the joints at the gearbox end are always in neoprene rubber. The gaiters on the joints at the wheel end may be in neoprene or thermoplastic, stronger but less flexible and hence more voluminous. These two variants are not secured in the same way and are not interchangeable. A few models, neoprene only, are fitted with rigid rings to prevent the gaiter at the wheel end from being centrifuged. These rings are made of plastic or rubber. Transmission systems can be affected by two main types of incident. Out of balance defects, resulting in vibration and requiring the component to be replaced. Bursting of the gaiter, usually at the wheel end. The grease is thrown onto adjacent components, the joint operates dry, and more dirt can enter. A transmission with a burst gaiter should be repaired by replacing the entire component, if it is noisy during driving, or by replacing the gaiter. A transmission system is repairable if its angular play is not appreciable. This can be estimated by clamping the transmission at one end and applying a rotational force at the other. Replacement of a gaiter requires a number of tools available in a kit, together with various attachment materials and tools. The items needed for repair consist of the gaiter, the attachments or collars, the required amount of grease, the circlips, springs, and safety devices. If the gaiter is made of neoprene, examine its outer profile at the widest part. If the area where the collar fits is narrow and edged by a shoulder, the gaiter has a single retaining bead inside and can be fitted only on an outer member with one groove. If the area where the collar is fitted is wide and without shoulder, there are two retaining beads on the inside, and the gaiter can be fitted only on an outer member with two grooves. The tubular shaft is a special case. The neoprene gaiters have no groove owing to their thin walls. As for the thermoplastic gaiter, it has very fine grooves. To replace the gaiter at the wheel end, the joint at the gearbox end must first be removed. Protect the bearing surface of the seal at the differential end with adhesive tape. Mark the position of the outer member with respect to the shaft so that the tripod rollers will be positioned on the same tracks during reassembly. Measure and note the distance between the two gaiters. Immobilize the GI with the support clamped in the vise. Prise off the cover. Remove the outer member, the spring, and the cap. Remove as much grease as possible without using a solvent. Remove the circlip with pliers. Press the tripod against the press plate. Mark its position with respect to the shaft and press out. Cut the collar and remove the protective assembly. For a thermoplastic gaiter at the wheel end or a tubular shaft, no positioning groove, measure the distance between the end of the shaft and the gaiter. Cut the collars and remove the gaiter. Remove as much grease as possible without using solvent. Position the new gaiter on the shaft. Distribute the requisite amount of grease in the gaiter and the outer member. Fit the gaiter over the outer member. Check that it is properly positioned by rotating the joint then adjust the distance between the gaiter and the shaft end. Fit the collars. Protect the shaft and grip in the vise. Fit the tripod. The chamfer should be at the opposite end to the circlip. Align the marks. And refit the circlip. Distribute the grease in the cover. Fit the cap and the spring. Align and insert the outer member fitted with a new O-ring seal. With the outer member in compression, peen the cover. Adjust the distance between the gaiters. Insert a welding rod between gaiter and shaft to create a vent. Certain gaiters have a venting ring. Tighten the collars. Each gaiter can be replaced independently. Protect the bearing surface of the seal at the differential end with adhesive tape. Mark the position of the outer member with respect to the shaft. Measure and note the distance between the two gaiters. Fix the connecting shaft in the vise in a vertical position. Cut the collars. Remove the outer member, being careful not to lose the rollers and needles, and hold them in place with the protective device of the correct size or with adhesive tape. The tripod is immobilized by peening into the shaft grooves. Mark its position with respect to the shaft and remove in the press. Replace the protector refit the tripod and immobilize it by peening into intact grooves. Continue reassembly. Attach a buckle in the end of the strap by bending inwards a length of about 2 centimeters. Determine the length of the strap by passing it twice round the gaiter and keep an additional length of 6 centimeters. Position the buckle with the hole outwards and following a first revolution, insert the slack end into the hole. Make a second revolution and insert the strap at the same point. Insert the strip into the narrowest slot in the pliers, 1 or 2 centimeters above the buckle. Insert the end of the pliers in the buckle and tighten. Cut off the excess and bend the end back under the buckle. Measure and note the distance between the two gaiters. Cut the collars and remove the gaiter. Screw the tapped sleeve and then the inertia extractor on the end of the shaft. Extract the outer member. Remove the clip and the gaiter. Fit the new gaiter and replace the clip. Compress the clip using a collar moderately tightened. Refit the outer member and remove the collar. Distribute the grease. Insert a welding rod between gaiter and shaft to create a vent. Adjust the distance with the other gaiter, remove the welding rod, and then tighten the two collars using the special pliers. Mixed transmission systems have a GI joint at the inner end and the ball joint at the wheel end. Each gaiter can be replaced independently. Before refitting, replace the differential output joint and clean off any grease thrown onto surrounding systems.